Good morning, ladies and gentlemen, and welcome to the SAIEE Building Services section webinar on a global perspective on revenue generating buildings. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. You will find the registration link in the chat box. Please register so you can receive notifications when we do uploads. And the recording of this webinar will be made available under the Building Services playlist. A certificate of attendance will be issued a few days after this webinar. Before I introduce you to our host this morning, please look at the handout section. You will find the October issue of the What Now magazine in PDF format and the SAIEE Training Academy brochure, which you please feel free to download. I'd like to introduce you now our host for this morning, Prof. Pat Naidu, who is a visiting scholar in the Department of Mechanical Engineering Science and Professor of Practice in the Faculty of Engineering and the Built Environment at the University of Johannesburg. He's a Fellow of the South African Academy of Engineers, a Fellow of the South African Institute of Electrical Engineers, a Senior Member of IEEE USA, and a member of IET UK and SAIEE in France. He's a registered professional engineer and a specialist consultant in electrical engineering, electrical energy, and power systems. Over to you, Prof. Naidu.
Good day. Thank you, Minx, and good day from Johannesburg. Thank you for your attendance this day. We at the South African Institute of Electrical Engineers have elected to shine the light on this part of the industry, that of buildings and its role that it will play in the changing energy landscape going forward. Building upon the fundamental that the sun is the sole source of all energy, we're going to share with you from three specialists their experience and their workings in this area of assets, as in buildings in the individual sense and as in cities in the community sense. Again, they're going to share with us their experience in deepening free, natural, renewable, sustainable energy in daily applications and on maximizing energy efficiency in that application process. First to share with us will be Jos Rolling from the IBM International Community, and Jos will lead the conversation. Jos is presenting to us from the Netherlands, and over to Jos Rolling. Minx, if you may introduce Jos, thank you.
For sure, thank you, Prof. Mr. Jos Rolling is a manager, associate partner, and executive architect at IBM's Global Industry Center of Excellence for Energy and Utilities, focusing on business transformation, business platforms, and IT/OT convergence. As a new energy thought leader, he has provided extensive support to utilities and new entrants in many areas, including transformational change, asset management, analytics, strategy development, and innovation in the provision of business platforms, increasingly around the seismic shifts currently taking place in the industry around distributed energy resources, renewable energy, storage, blockchain, tokenization, viewing data as an asset, and the transition to a digital utility. Over to you, Mr. Rolling.
For the introduction. And I need to share my screen. So as explained in the introduction, yes, so I'm electrical engineer by trade, spent my career in IT, and I'm very thrilled to present today some of the projects that I've been working on. I'm part of the Global Center of Excellence within IBM for the energy sector, having and supporting projects globally. And buildings is one of the aspects that are very near and dear to my heart, and also to understand the different aspects of buildings what we will address a little bit later on. For those of you not very familiar with IBM, a very short shout out. So it's an international IT company We exist for over 100 years, and we provide you with products. Here mentioned as infrastructure in different servers and storage solutions, hybrid cloud platforms with our sub-brand Red Hat. We have a large software portfolio, and I'm part of the IBM Consulting organization, which helps you do business transformation, technology consulting, and application operations. Now, for today, I broke my presentation in two main parts. So the first part of my talk will go around success. And there are two major aspects to that. One is what are the criteria for success, and how to set up yourself to be successful if you want to do more intelligent building operations. If you are then satisfied in these two elements, those are very critical in our analysis of successful projects, then only we can see how we can then leverage market access, and I will dive into how the IBM Flex platform can leverage in that some benefits in that ecosystem. So I'm not an expert by any stretch of the market in South Africa, but I did some reading. And I think that it's quite in flux. That's my keyword after having a brief understanding of what's going on. So there is quite some changes going on. And it says here that the new laws and the new proposals will shift and will have a big impact. And that means that when you then prepare for a project, that's an element that you need to address, and you need to also understand what's the good moment in time to start off your project. Not too early, because then you'll receive and will experience a lot of changes and a lot of risk in your endeavor, as we have experienced in Europe as well. And then I learned that there are two new market structure proposals on the table. One is the specification here on the left, and on the right is the energy code, so the more detailed, more legal specification of that new market setup. I think that if you want to embark on energy trading buildings in South Africa, then you need to have a very deep understanding of those new specifications and a new code to see where you need to comply to. So you are prepared and can start and be first and leverage the first mover advantage for your project. So that's work to be done. It's just proposed earlier this year, so it will take quite some while, I think, if I look at the European processes before it's agreed, finalized, and accepted and rule of law. So currently it's only proposed, is my understanding. Now, going into why would you be interested in buildings, and why do you want to be interested in and understand the energy transition at large? Then the current energy mix, as reported in 2022, is for energy generation in South Africa. Coal is the majority fossil fuel to be used so far. And there was an announcement on Reuters end of last year that the South Africa government has decided to delay the closing of those coal-fired power plants. So that means that there is some delay, and still the Paris Agreement and all the commitments there are still valid. So that gives quite a tension, I think, in South Africa to see how you can then meet or delay the reduction of emissions as being internationally agreed. So that's a force that will play into and have impact into the political environment and also the market structure, and also then as a result the financial elements. And then a final one on the context is that if I look at the energy prices, which you can look up on the internet, then I see on the top the most expensive energy prices are found in Denmark and Germany. So those are two Northern Europe countries with a very large portion of wind energy. And I think that the prices are there around $53 per kilowatt hour. I think I have not managed that and analyzed it in detail, but my understanding is that a lot of those costs are associated to pay off the subsidies of the build out of those offshore wind farms. So if you compare it to South Africa, with only 15 cents per kilowatt hour, it's on the lower section of this long list of countries and energy prices. And then if I then read the quote on the top, that the new Energy Act will then lower energy prices for all. And you want to shift from your fossil fuels to renewable energy, there is intention, because currently countries that already started their journey, I think 10 years back, did not receive an energy reduction, the lower price in energy. So as seen here in this slide. So that's also to take into account for your business case, where the risks are and how those developments are being projected. And you need to be then, I think, for those projects, be very sensitive on how the prices will develop. So that's, I think, the two major elements. So because these two aspects, so market deregulation and market prices, and then energy prices for your buildings are the inputs for your business case. And that's something that's turned out to be a crucial driver in a lot of projects that I've seen. So and that means that if there is a slight risk or a slight uncertainty there, that will be then a blocking issue for your project. The rest of my talk goes more in how market access platforms are being created and how that development will go. And then the major part of my talk will go around the IBM Flex platform, which originates in Denmark. And then you immediately get the understanding that in Denmark, the prices are very high, 3.5 times more expensive than in South Africa. And in that country, it makes sense. And we tried to replicate that platform more to the South European countries with lower energy prices. And there, the success is still to be found. We found that the financial setup is very crucial for the adoption of those platforms. So let's then look into the market access. So in Europe, there is a huge program running by the NCOE, which is a foundation for the transmission system operators to build a harmonized market model. So we are harmonizing all market structures in Europe towards one model. As a result, there is a mandate from the European Commission to open those markets for consumer participation. So, the first steps are implemented in 2016, where I was involved in building the joint venture Equity, which is running a market access platform for virtual power plants. To show a little bit what the context is, that we have seen a shift for the last 15 years from conventional generation using fossil fuel to sustainable generation with wind and solar, from large centralized power plants to more decentralized, smaller units of generation, and from a very predictable load and controllable generation to a very unpredictable load and intermittent generation due to weather conditions. And that means that there is instability in the grid, and that all has to do with the mismatch between the intermittent generation and the load. So there is quite some flux going on. There is congestion as industries are electrifying, transport is electrifying, residential heating is electrifying. So and it all gives congestion in all grid levels. And as those developments are less predictable, we see very, very more volatile markets. And we are convinced, based on quite some analysis in 2015 and ever since, and also in our project experience, that we need to increase flexibility. Yeah, and you can only unlock the flexibility if you implement a smart grid, an intelligent network, intelligent market, and digitizing your assets, yeah, like your buildings, to make use and to navigate of all the opportunities that you can find. And one of the major ones, if you go to renewable energy, is the balancing of the grid. So, and in Europe, we have there a number of markets grouped in the ancillary service domain. And back in the day, in 2016, normal spot prices were around 200 euros per megawatt hour for balancing, so fast frequency response. There was a projection that it would rise above 500 euros per megawatt hour, which was then considered a high price. And we experienced this year in that same market spot prices of 1,250 euros per megawatt hour. So we see a steep increase in the pricing of those balancing products. And if those prices are indeed rise to that level, then it becomes a good input for your business case. Yeah, but you need to be very aware and analyze also the long-term development of those prices, because it can also be that with the installation of more and more behind-the-meter batteries, those price peaks will be flattened. Yeah. So and to give you another data point, so congestion cost in Germany exceeds 1 billion euros on an annual basis. Yeah, so and the congestion in Germany was caused by the subsidized offshore wind farms in the northern of Germany, while the heavy industries that want to electrify are in the south of Germany. And that north-south link is a high voltage connection, and that's huge congestion is experienced in that network, spilling over that congestion into Poland and into the Netherlands. Yeah, so quite some international aspects there as well. So in the platform that IBM has created and is now in the hands of Equity is now supporting the same market access in 5 countries. So in the Netherlands, in Germany, Austria, Switzerland, and Italy. And the availability of the APIs and the access to the market is gaining more interest for all kinds of manufacturers and traders, because it's a single interface, and then you can access the markets of those 4 or 5 countries, which is economically very attractive. So that being said on market and market access, I want to shift gear now to the IBM Flex platform. Which is initially designed to unlock flexibility from buildings to trade on energy markets. But it's safe to say that we also find other applications like water treatment plants and supermarket chains to have some flexibility that can be unlocked as well. So we start again. We understand the trends like already explained in the previous section. But there is an opportunity not only to reduce your energy footprint, but also to reduce greenhouse gases. As with our balancing, with our IBM Flex platform, we can contribute to the balancing on a very sustainable way, and then prevent gas-fired peakers to come online and compensate for the imbalance of the grid. So there are quite some different benefits that we are then stacking upon each other. So the way the the platform works is that giving the assets on the left, which has some flexibility, and I'll come to that in a second. Yeah, so that flexibility can be from EV charging, that can be from behind-the-meter batteries, that can be from air conditioners, that can be on ventilation. So all those electrical appliances you find in your buildings, we connect it using an IoT connection to our platform. We run an artificial intelligence engine to understand and to optimize, and we have an underlying blockchain to record all the different agreements between each building or asset within a building, the aggregator, for making sure that the benefits that are being traded on the markets, and that's initially the balancing of the grid. So that will be ancillary services like congestion, like curtailment, but also fast frequency response. So those are then the markets that the flexibility is then being traded on. To give you an artist impression on the AI engine that we developed, is that if you look at all the different aspects of energy flex, then it means that you need to know what's the potential that your building can provide that flex, because some periods of the day it might not be available. So what's the total potential, and then how often can you then execute that flexibility? So ramping up or ramping down the energy consumption. Yeah, so ramping up your air conditioner or slowing it down. How fast is it responding? And then how much is the change? Yeah, so sometimes it's only a minor change, and sometimes you can totally switch it off. And then you have how long you can run in that state. Yeah, and that all together gives you the flex profile. And each device has its own typical profile here, indicated in the different color blocks that you see. And then in the AI engine, we understand those different shapes, and we optimize the portfolio. Yeah, like visualized here on the right hand side on the top. So done the analysis and running the programs and the projects. Here is some key metrics that you can work with on the flexibility profile. Yeah, so for heating, ventilation, air conditioning in Europe, we find the potential of flexibility of 30%. Pumps 25%, electrical motors and industrial equipment usually 10%. Cooling and freezing as a potential of 70%, and electrical vehicles also 70%. And electrical vehicles is then usually the charging plazas in parking areas, yeah, associated to corporate setups. Yeah. So and for Northern Europe countries, building will take up 40% of the total energy consumption. There is 25% of flexibility, yeah, in those buildings, and the flexibility is very interesting to see that the old buildings that we find in Europe, like 100, 200 years old, have less energy flexibility than the modern buildings with large atriums and glass facades. Yeah, so those buildings have much more flexibility. Yeah, so and that's to do, I think, with the construction setups that were used in the past. Now, to dive a little bit deeper in the technology aspects of our IBM Flex platform. So on the right-hand side, you see a conventional kind of setup that you might consider. Yeah, so you install controllers in your building. You install submetering to understand what's going on. You have multiple communication modules to get all the data collected in the central point. And it means that there's quite some engineering and some renovation needed in order to be prepared for unlocking the flexibility. That's not the approach that we have chosen with our IBM Flex platform. We understand that most corporate and industrial buildings already have a building management system. So, and the only thing that we do is we connect our platform to that building management system using MQTT, a lightweight IoT protocol. And that's the only integration that we need. You know? So, and then we are using the building management system to change the set points. You know? So traditionally, a building configured and set up, and then it goes into operational phase. So, and then our setup is that when you hook up your building management system to the IBM Flex platform, we first go into 2 weeks to 4 weeks AI training mode. So we only receive the data from the BMS, we receive some weather data, we receive some other data points that we think are necessary, and then we train our AI model on your specific building, the building behavior, the energy profiles, and also analyze what type of assets are running within the building, because each asset type has its own profile. So we have pre-trained our model with those different profiles, and we fine-tune it, giving that building characteristic. And after that training period is over, we switch, we flip the switch, and we go into trading mode. And then the building starts trading the flexible energy on the market, using that aggregator platform from IBM Flex, and to make some revenue on the different markets. So to give a little other view on that, yeah. So the Flex provider on the left here, those are the buildings, the assets that you find in the buildings. Sometimes we have also a connection with the OEM, so the manufacturer. So from Trend Micro or Schneider Electric or Siemens or whatever, the building management system or a large asset behind that building management system is working to get as rich data as possible. And the Flex provider, that's the commercial entity that is leveraging the IBM Flex platform as the relationship, so with the aggregator, and the aggregator is then the one that has access to the market and does the trades, and that is needed because most markets have a minimal bid size. So there are some constraints there as well in what the minimum bid size is, and an individual building usually do not satisfy those requirements. Now, finishing off the IBM Flex platform, showing what we have. So this is an example, a little bit an artist impression of the city of Copenhagen, which was the initial client of the platform. So we have quite some opportunities to the settings. So onboarding of properties that are in your portfolio, onboarding the assets, setting consumption profiles, setting up overrule settings, so that the platform can be tuned to your own occupation and usage of the property. Then setting up the Flex agreement, the agreement between you as a portfolio owner and the aggregator trading it on the market. You have quite some dashboards showing the emission reduction that's being achieved by providing the flexibility on the market, and also on the financial part. And you for sure have also all the operational metrics that you're looking for. So for your reference, I've brought here 3 scenarios. One scenario, if you have only 5 megawatts of flexibility in the Danish market, it has an annual revenue of 300,000 euros, and it saves you 730 tons of CO2 emissions, all the way to 20 megawatt flex. Yeah, that gives you then 3 million revenue and almost 5,000 tons of CO2 emissions. So if you are interested in setting up and engaging in such a project, step 1 is the potential analysis. So that means that understanding the local market, understanding the price points of the market, understanding the accessibility of those markets, which are easily accessible, which are more harder to enter. And that gives you then a full understanding, is it worthwhile to start a project? And this is where currently the most success criteria are being then identified. And if we have then say a potential interesting environment and setup, given your portfolio, given the market, then we run a pilot with one of your assets in your portfolio to validate it, to get experience, to get all the agreements in place, to get all the technical aspects done. That is usually not that hard. And when we are embarked on a couple of assets or buildings in your portfolio, then we can go scaling. And scaling is then one for your as an owner of multiple buildings, but also scaling for the aggregator to get more clients in order to get volume to be leveraged on the market. So yeah, the IBM Flex platform, I think it's a more an ecosystem kind of approach that we have taken. So it is a systems of systems. So we don't replace, we leverage what's already there. We do rely on mature markets, so we have then a good understanding of how the price developments are going. We have built quite an ecosystem, and we are extending it as we speak, with multiple suppliers and aggregators in different countries. And we have now been working with selected clients to validate and scale out the platform in order to have a lower emission by supplying flexibility based on the building capabilities, while also having a good business case for both the building owners as the aggregators, as the economy as a whole. So here's what I've prepared. I don't know, I could not see the question in the Q&A during my talk, but if there are any questions, then I'm available, and if not, I can hand over to the next speaker.
Thank you very much, Mr. Rowling. Appreciate your presentation. Ladies and gentlemen, please, if you have a question for Mr. Rowling, which we'll get to after our third presentation, please just type his name in the beginning of your question, then we'll pose the question to him. Thank you. I'd like to introduce you now to our next presenter, Mr. Mike Barker, who is a consulting electrical engineer and building services specialist with over 30 years of experience in energy systems for a sustainable built environment. He holds a BSc in electrical engineering from the University of KwaZulu-Natal. Mr. Barker has worked on many of Southern and East Africa's sustainable buildings, including the Durban International Convention Center, stadiums, and, for example, the Valpre LED Gold Office in Heidelberg. In addition to his building services experience, he consults on sustainable buildings and smart campuses in cities. Over to you, Mike.
Thanks, Minx. Just going to share my screen. And that should be coming up soon. Okay, so the focus is on not only profitable buildings, but profitable microgrids. I'm wondering if you can see the screen, Minx.
Yes, don't know why I'm still seeing Mr. Rowling's presentation, and I've made you presenter. There we go. I see it. Perfect. Thank you.
Okay, great. So let's just switch off the old camera, conserve some bandwidth. The focus today is on, I guess, things that have been happening in our immediate past here in South Africa, Southern Africa, which is really the issue of load shedding and controlling electricity. And one of the first things we've got to do is look at a bigger picture, because buildings, we understand, are owned by people with money in mind, the property investors, the property owners, and the real estate market is a massive market. So I'd like to take you through what is a bigger picture, looking at who these decision makers are and the way they think. at the top of the agenda, I would think, in most boardrooms, and certainly over the last 10, 15 years, has been business continuity and discussions around the dinner table too. What it comes down to is the real estate investors can live with higher priced energy, and by and large, they can live with the carbon and greenhouse gas emissions issue. In fact, to be blunt, they tend to ignore that. But what is very difficult to live with is the lack of electrical energy. So business continuity clearly is going to be one of the top items in any discussions around a boardroom table.
Sorry, Mike.
Yes?
Mike, my apologies. You switched off your presentation and kept your webcam on. I'm just going to take the screen back to myself and then just make you presenter again.
Okay, thank you.
Okay, let's just do that again. Okay, apologies, attendees. Thank you for informing me. I thought I was dreaming. Okay, let's just make you presenter again, Mike.
Thanks, Minx. Let's try this out.
Okay, your webcam is still on.
Okay, I want to switch webcam off. And we should be looking at screen 3. Tell me if that's the right one.
That's correct. Please proceed.
Yeah, okay, so we were talking about business continuity, certainly a very important part of any property owner investor. And of course, what we are very aware of is the government fully understand the issues as well. And their thinking, it would seem, is that certainly if Eskom can't do the job, the end user should start looking at supporting and maybe generating his own energy. And that's a lot of what the discussion today will focus on. Now, the interesting thing is, of course, that a lot of South Africa's issues are self-inflicted. We all know why. But overseas, the energy crisis tends to revolve around climate change. In other words, heat waves, floods. Any of you who have friends in Florida, in the USA at the moment, will be well aware of the occurrence of two, I think it's a 1,000-year flood and a 100-year flood in the space of 2-3 weeks. So climate change is a pretty big thing. And we have every confidence, I think, that Eskom are going to sort out the load shedding issues, but they can't do much about climate change. So we have to start thinking about these particular issues, revolving around everything from heat waves to tropical storms, cyclones. Many of you who can remember 1984 will remember Des Moines that tore through northern Natal back then, KZN, a massive loss of infrastructure. And more recently, we've seen a lot of these cyclones moving across the upper part of Mozambique. If one of those cyclones should head south, and there's a good indication the Wits people are talking about it, it's quite possible that not only would it affect the coastline, but it could tear into the interior, reaching as far as Gauteng, and certainly the power generation plants out in the Eastern Transvaal area. So we've got to think of a lot of these things. A couple of photographs just to entertain you. This was taken near the Vaal Dam a couple of years ago. And the interesting thing is you can see the Eskom power line there in the background. So an EF3 tornado can travel 30 k's. It'll certainly take out power lines as it does all over the world. And it's about time, you know, we start realizing these are issues. People tell you that the tornadoes only occur in the Platteland. So here's a twister on the Johannesburg skyline. I think we're going to see a lot more of them. Certainly the climate people are talking about these particular issues. So what really happens is the tornadoes tear through power lines, lifting a lot of debris, and the debris itself tends to damage the power lines. And on occasion, as we saw in the Karoo, the high winds and possibly tornadoes can bring down pylons as well. We've seen that as well in the DC link up to Kahora Bassa. It all gets you thinking about resilience, and property is probably the largest asset class the world has ever seen, far bigger than utilities, Eskom. And because they have a strong interest in resiliency, that, as I said, they can live with the cost of energy, they can live with the carbon issue, which is substantial, but what they can't live with is the lack of energy, the resiliency. So we're going to see a very strong interest in how to address that problem. Okay. Now, everybody wants the electricity the way good old Mother Eskom dished it up. Plentiful energy, cheap energy, always available. But we're moving into a different world now, and there's a strong and sustained interest in the need to self-generate for self-consumption. And of course, the profit tends to go into the pockets of those who own the buildings themselves, the commercial and residential estate. So the focus, I think, if you talk to anybody, and Yosh and IBM are looking at it as well, is to electrify not only Europe, but we should look at electrifying South Africa. And whilst we talk about self-generation, self-consumption, we need our buildings to be good grid citizens. We're not talking about leaving the grid. We're not talking about grid defection. We're talking about staying on the grid, working with the grid, grid interactive buildings, and being good grid citizens. And why are we doing that? Are we perhaps trying to save Eskom or anything along those lines? And the answer is no. We want to be able to buy and sell energy over the grid. In other words, energy trading across the grid. So that's going to be the focus, I think, of commercial and residential. A lot of the older engineers will snigger at the thought of buildings being able to provide a lot of their own energy. So this is an interesting stat that comes from Saturday, this Saturday past. Over in Australia, their main power grid had 50% of the energy supplied by rooftop solar, not solar farms, not wind, just rooftop solar. And of course, you can see that it's for a short period when the sun does shine. But what we're noticing around the world is a lot of the rooftop solar is supplemented and supported by a range of energy storage systems, all the way from ice storage, thermal storage, through to the all-important electric battery storage. The song that we're singing and have sung for the last couple of years is simply this: PV on the roof, EVs on the parking, and batteries in the basement. And I think we're going to see that having a major impact on profitable buildings in the near future. So our colleagues, professional colleagues in the quantity surveying field, the RICS people, the property developers, property owners, have taken a pretty careful view on the value of resilience and the impact that weather events have on property values. And there's the strong and growing interest in ensuring that energy is available to buildings 24/7. It's also interesting to note that our friends, the architects, whether it's the Royal Institute of British Architects or AIA, American Institute of Architects, are starting to understand that they need to design their buildings with energy systems in mind, not only just PV, but space for batteries, space for charging of electric vehicles. And recently released in the States is a set of guidelines for architects, building design with the grid in mind. This is the grid interactive building, and once again, the whole idea of that buildings have to work with the grid. Taking it a step further, if you've heard of the United States Green Building Council, they're tending to move away from the older metrics. Now, here in South Africa, we've got our Green Building Council, and we've got star systems, a couple of star, 4, 5, 6 stars, whatever. The focus now is not on how much energy you use, the focus is on when you use the energy. And we have issues such as hourly matching. We want 24/7 carbon-free energy and a whole new set of metrics coming out. And as we've heard from Josh in the previous presentation, a lot of building strategies are being looked at. Load shedding, peak shifting, in other words, shifting, shaping, shedding of the load. And the architects play a part there as well with shading, orientation of PV on the roofs, orientation of the roofs themselves, and of course a lot of control, dynamic response, and the storage capability as well. So all of these are fairly well known. The IBM guys play a very big part in the smart buildings community around the world, so you'll hear a lot more of them, I'm pretty sure, once we start digging into smart buildings. And I certainly hope that the Institute itself will be playing a larger part in promoting smart buildings, not only to government, but of course to the people who own the buildings, the decision makers. Okay, the IEEE Power and Energy Society, about 48,000 electrical engineers around the world, have got a slight problem because they've always been the utility engineers looking from the top down. These days, prosumers have the ability to generate local energy, and we start looking at flexibility from the bottom up. And the IEEE Power and Energy bunch have got a technical committee focused on smart buildings, loads, and customer systems. And I'm part of one of the many task forces and the committees, and my job is to help the energy dinosaurs, meaning old people like myself, old electrical heavy current engineers like myself. We've got to change the way we think. It's no longer top down, it's bottom up. The prosumers are going to play a very big part, and every building that you can think of is going to have a microgrid. Microgrids are not new either, just by the way. Here in South Africa, we see a lot of microgrids. ABB, Siemens, Schneider, GE, Eaton, a lot of microgrids in South Africa, pilot sites, some of them, and we're going to see a lot more. How do microgrids play a part? Well, they're going to be the foundation of a modern building or be retrofitted into existing buildings. So this slide I'm showing you, I've had this slide and used it on many occasions, many presentations for about 10 years now. And right from the beginning, I think we all understood that smart buildings are not only going to be a smart load on a future smart grid, meaning a microgrid, but buildings are going to be both a power station and a petrol station. And that's where profitable buildings come into the picture. If you want your building to be profitable, you're going to have to start thinking about how you're going to be supplying energy to a whole new market, because a building is the natural home of the electric vehicle, either inside, next to it, or visiting. Electric vehicles are going to be relying on buildings to provide power, and that's a potential profit source, and we've got to start thinking about that. Now, here in South Africa, we're quite far behind the curve when it comes to electric vehicles. Most of us are not aware of what's happening around the world, and certainly in China. I think there's about 4,000 or 5,000 electric vehicles in South Africa at the moment. In the UK, I think it's 30–40% hybrids and electric vehicles were sold in September. I mean, they're just flying out the door. How do we get South Africans to take electric vehicles seriously? And we all know the answer: double cabs, 4x4s, buckies. So every one of these vehicles I'm showing you here is an electric Chinese bucky. And I think this will certainly get their attention once they start flooding the market. The Chinese are being edged out of the US and Europe tariff-wise. So they're looking at South America and certainly Africa. The other interesting thing is, by the end of this year, and probably by the end of next year, the cost of an electric vehicle is going to be lower than the price of an ICE vehicle, an internal combustion engine vehicle. And I think because the Chinese are producing good quality vehicles that are certainly of a cost equivalent to that of the petrol diesel engine vehicles, I can't see how we're not going to have many of them in Africa and South Africa. And it's not only these large buckies, but certainly three-wheelers, two-wheelers. That's the sort of stuff that Africa needs as well. And we're seeing that happening. And I do a lot of work in Kenya, the tuk-tuks and the boda-bodas, the little motorcycles are all turning to electric. So I think we're going to see buildings playing a very big part in providing energy to electric vehicles. Okay, so that's the big picture. And I'm certainly hoping that that sets the scene for the second part, where I want to talk about profitable microgrids and buildings. And this is a shorter presentation, a technical presentation. So some years ago, as a case study, an unofficial case study, I must admit, I took the head office building of a large South African company that is reportedly seeking to reduce their energy costs, reduce their carbon footprint, and I think there's a strong interest in increasing resiliency. So I was able to get quite a bit of data out of their efforts with their head office. They've got existing PV, you can see here on their conference center area, a lot of PV. They've got a fair amount of PV carports and some electric vehicle charging in front of the main entrance of the building. We know they've got a lot of chiller plant. We know they've got a fairly large diesel genset farm. So using various software, I set about trying to build a techno-economic model to better understand how one would go about providing and building in retrofitting a microgrid into this head office and adding a whole lot of extra services that they may need. So for a start, I said, well, look, we should look at maybe a new fuel cell. There is gas, Sasol gas in the area, believe it or not, out Midrand. There's a pipeline coming through. I said we should look at a very large and new battery system. We should look at new photovoltaics, if you can see my cursor. And we should look at V2G, using the electric energy from the batteries of EVs, of electric vehicles. And let's put it all together with a microgrid controller and see where we go. So the software we were using is, and there's many different software packages. The one that I use quite often, because it's open source and it's not a black box, is a package called DIRCam from the US. In South Africa, a lot of us use Homer, a very good package as well. Homer is a black box to a degree. Each of them have their strengths. So how does DIRCam work? Well, quite simply, on the left-hand side, our input data would clearly be the tariffs, the cost of energy, and we can put in some very detailed tariffs. We then look at the load profile of the building, and I made some assumptions on the load profile of this headquarter buildings over 24 hours, so that's the consumption profiles. I then gathered weather data. That's easy enough to get hold of. But what I did do is, working through my colleagues at BIPSA, the International Building Performance Simulation Association. For my sins, I happen to be a committee member for the last 20 years or so. So we have a range of weather profiles and weather data for the years 2030, 2040, 2050. And of course, when you do techno-economic evaluations, you're looking 10, 20, 30 years ahead as well. So we plug that data in. As you can imagine, the weather data indicates things are going to get a little bit warmer and there's going to be more extreme weather events. We plug that sort of data in. And then, of course, we pick up on all the DER technology, with DER's distributed energy resources, batteries, generators. And my interest, of course, is in the CapEx and OpEx. So the performance, not only in technical terms, but performance in terms of cost, CapEx and OpEx. We pump that in, put together some sort of network configuration. And then we say to ourselves, what are we trying to do with this model? And clearly, reducing total energy costs is important, and I'll go into that in a little bit detail later. CO2 emissions, yeah, well, if you can reduce your carbon footprint, there's a wall of green money looking for good green projects, so maybe that's important. And then certainly over the last 15 years or so, reducing outages, ensuring energy security, a very big thing. So we plug in data and we'll say to ourselves, do we want to ride through a 2-hour outage, a 4-hour outage, a 1-week outage? And you put that sort of data in, and decisions will be made by the system. If you want to ride through 1 week, the first thing the system does, looking at the price of diesel fuel and gensets, it'll chuck a couple of big generators in. Fuel cells are still too expensive. Look, so all of this is of great interest, but at the end of the day, the results are going to be cost and performance metrics. We're looking to see what the new technology investments should be. Capacity sizing, operating schedules play a very big part, and where to locate these assets, energy assets, within the local microgrid network. Just going back to this year, we can see we had suggested to the system that we wanted to look at fuel cells because we knew we had gas. There was space for a lot of PV, and of course the batteries and the V2G battery. So the decision that, and the optimum investment that Durkheim came out with for this particular project was, as shown here, 2.6 megawatts of new fuel cell, 5.2 new PV, and it based this on the cost of energy, the cost of photovoltaics. This study was probably done 4 years ago. I think I reran it 4 years ago. So a little out of date. But notice that there's a big, an important use of the V2G capacity. And this could have been a lot larger. In other words, reducing the capex spend of the building owner on batteries if you can start making use of all the electric vehicles in the parking lot. And basically, that's capital that's free to use. So just taking it a further, let's just look at the profile, a couple more slides, and then I'll be done. We've got, and you can see that the tariffs reflect probably 4 years ago, the tariffs. So this is time of use tariff. We know the winter hours, in this case, the winter tariff, we looked at that. So this dotted blue line with the squares is the load profile, the existing load profile of that building. You can see they knock off at about 4 o'clock. And there is some activity at night, security lighting and other, I think they've got a couple of IT centers and things like that. The gray line is the new load profile once we start looking at how we can dispatch our energy resources, the various assets that have been suggested. So the game plan here, these blue bars represent the energy used from the grid, and you can see the whole idea of this headquarters microgrid is to switch off the grid during the hours when the tariffs are very high and try and use a lot of energy when the tariffs are low, such as in the late morning. If we look at the next slide, you'll see how the new photovoltaics start playing their part. And you can see we generate excess photovoltaic energy in the middle of the day. And some of that, of course, then is pushed into batteries and stored. We're not pushing any energy back into the grid for various reasons, mostly because we don't think that you'll get paid. And there's always a danger at the stroke of a politician's pen. Any feed-in tariffs, net tariffs can be cancelled, as has happened in Spain, for example, and then you're left in a very awkward position. So our approach is not to push energy back into the grid or even try and sell energy. We want to self-generate for self-consumption. And then the next up is to look at the contribution that electric vehicles can make. It could have been larger because I've only assumed that we're going to look at 100 Nissan Leaf vehicles and pull energy from them. And the way the V2G works is we set up the approach in the DIRCAM system, and we talk about the minimum state of charge. So we never allow a vehicle to leave with less energy than when it arrived. Right? We're assuming that a lot of vehicles will connect to the V2G wanting energy, and they're going to be there for the 5-6 hours in the day. In other words, staff cars, people arrive early in the morning, they park. So we never let a vehicle go home with less energy. We always give them energy, which, you know, we hope they pay for. But during the day and early in the morning, we pump them full of energy so that we can draw out that energy at a later stage. And that's the sort of game plan you play, and you set it all up in software packages like DIRCAM. And it's, you know, this is how vehicle to grid will work. So that takes us through to the big picture, and you can see here where the new battery system and the EV batteries play a large part when we voluntarily island ourselves from the main grid and use only local energy, whether it's from the fuel cell, from the batteries, from a little bit of solar when the sun does shine. Clearly, the particular 24-hour period we're showing you here does have the sun shining. You know, we can show you details what happens when the sun doesn't shine, and that's where we make better use of the fuel cells, and on occasion the diesel gensets will kick in, because it is, you know, economical to a degree to run the diesel gensets when the time of use tariff is at a peak. Okay, so that gives you some background on how a microgrid would work in a large commercial building. And we're very keen to see that the buildings should be seeking beneficial coexistence with the grid. I need to underline that. This is never going to be about grid defection. This is never going to be about separating yourself and seeking to live off grid at all. We need everybody to stay on the grid so that they can trade energy. That grid belongs to every South African, and I believe we've got a constitutional right to buy and sell energy over the grid. We do have to be aware, though, I mean, in an ideal world, the magical grid will have infinite capacity and be run by a benevolent charity, so that in theory you can sell all your little bits of energy to them at a moment's notice, and you know, you'll be rewarded. In the real world, though, when you have an entire neighborhood, in other words, your local feeder is PV rich, every building on your local feeder has got a lot of photovoltaics. In the middle of the day, I think we're going to see an excess of photovoltaic energy. And the grid may be unwilling to pay you for that energy, and in fact, you won't be able to trade that energy because in the middle of a sunny day, everybody's going to have excess green electrons. So, you know, you've got to start looking at a lot of thermal storage, shaping, shifting, shedding of the energy. So with that, I'll leave you, and hopefully we'll get a couple of questions out of this. And I'm certainly looking forward to talking to Aaron and Josh at the end of this, trying to understand a bit more. Thanks, Minx.
Thank you very much, Mike. Appreciate your presentation. I'd like to now introduce you to our next speaker, who's Aaron Shivara, who is the chairman of the SAIEE Building Services section. Aaron is an accomplished entrepreneur and leader with who utilizes the dynamic combination of a BSc in engineering and MBA and project management skills with experience in engineering operations, maintenance, and strategic management. He received his BSc Engineering Honours from the University of Zimbabwe in 1987 and his MBA at the University of Pretoria in 1999. Over to you, Aaron.
Thanks, Mix.
Let me just make your presentation. Yes, please proceed. Let's see.
Don't know why it's not coming up.
Okay, let me just take the screen. I can see your GoToWebinar screen. So you are sharing your screen. Just open your presentation, PowerPoint,
Yeah.
and put it in presentation mode, please. There we go. Please proceed.
Okay, good day to you all. Today, I'm going to share with you a proposed vision for the building services section of the SAIEE. We need to bear in mind, this is a proposed vision, and as such, any additions, deletions, improvements, or enhancements are most welcome. So let's dive right into it. I see the establishment of the SAIEE building service section as a platform that brings together engineers, technologists, and industry professionals to drive excellence and innovation in building services. In order to achieve that, we need to embark on a journey that seeks to promote leadership, technical knowledge, and standards within the building services field. The journey aims to achieve a number of core objectives. And I think here the core objectives would be fostering collaboration and knowledge exchange, supporting professional development, advocating sustainable and energy efficient business building practices, and driving research and innovation in building services. This journey aims to focus on a number of key areas. I've listed a few of these and I'm going to share them with you. The first focus area would be electrical engineering for buildings. This would focus on the design, installation, and maintenance of electrical systems. The key areas would be lighting, power distribution, fire alarms, security, and smart buildings in order to ensure energy efficiency, safety, and integration with modern technology. Another focus area would be HVAC systems, where would focus on design, installation, and control of HVAC systems and indoor climate control. This would be aimed at optimizing energy consumption, improving occupant comfort, and promoting health through proper air quality. A third focus area would be plumbing, water, and waste management. This covers wastewater supply, drainage systems, and waste management in buildings, with a focus on sustainable water usage and smart water systems to ensure conservation, safety, and hygiene in buildings for environmental sustainability. Another focus area would be building automation and control, which covers automation technologies for controlling building systems. And the focus is on smart buildings, Internet of Things, and energy management systems. This would enhance energy efficiency, occupant comfort, and facility management through automation. Would also focus on fire protection and safety, where we focus on design and the implementation of fire detection, alarm, and suppression systems. We would focus on meeting regulatory standards and ensuring safety. It is critical for safeguarding lives and property in the event of fire and other emergencies. And I think finally, we look at sustainability and green buildings. This will look into the integration of renewable energy, energy efficiency, and low carbon technologies in building design and operation. I would focus on building certifications like the Green Building Council of South Africa's Building Star Rating or government's energy performance certification and energy modeling. This will be done to reduce environmental impacts and promote sustainability and align with national climate goals. It's a very short presentation, and I'm saying, please join us in the future of building services. Any participants who so wish, please become part of the SAIEE Building Services section. Let's engage in the upcoming events, webinars, and workshops that are being prepared. Let's collaborate with industry leaders and innovators to push the boundaries of engineering the built environment. And for those who are interested, please express your interest by sending emails to the email listed here, bssection@saiee.org.za. That's a short presentation, and thank you.
Thank you very much, Aaron. Ladies and gentlemen, we're now going to take questions. I don't see any questions posted yet. If you have questions for any one of our presenters, now is the time to post your questions. And while we wait for any questions to our presenters, as Aaron said, without your support, we cannot have a successful building services section. So please, if you want to get involved with the webinars we're planning and the events we're planning, please email us a copy of your CV, just a brief CV or bio, to bssection@saiee.org.za. Any questions from the audience? Let's give them a few moments. Mr. Rowling, while we wait for any questions, any closing remarks from your side?
Yeah, so I have a question for Aaron. Yeah, so thank you, Aaron, for your call to action and your initiative. Well structured. So, but one thing that I was wondering, and perhaps I did not understand it correctly, do you also plan to focus on MRO, so maintenance, repair, and overhaul in your initiative? Because I had the impression, but perhaps I'm wrong, that you set out more for new build environments, and I think there is also a good opportunity to refactor in and address existing built environments in your same lines of thinking and improvements.
Yeah, okay. The focus is not only on new buildings. We are looking at things like using AI in predictive maintenance, in smart energy management. So yes, maintenance is part of the thinking.
Yeah, Aaron, if I can just jump in there as well, we do know that the number of facilities managers throughout South Africa are actually engineers, electrical engineers. So I quite expect that they would be joining up, and therefore strong interest in the retrofit market. In my personal opinion, every building needs a microgrid. So there's a hell of a lot of work for electrical engineers in the next 10 years. Thank you.
I've got a question here to Mike from Mr. J.H. van Heerden. Are there any facilities that are currently using fuel cells practically in SA, or is this still a theoretical concept mostly?
Yeah, so that's a good question, because as you know, the South African government are keen to support hydrogen, and you know, you can quite imagine with the platinum available in South Africa and the hydrogen, we would certainly see a lot of work. The one fuel cell I know of was installed in I think it's one of the mining headquarter buildings in the middle of Joburg. I don't know. Last I heard, it wasn't running. I'm not aware of many commercial fuel cells running, but I think Potch University have got a couple of pilots. Cape University of Technology have got a couple of pilot fuel cells working. Still early days for fuel cells. I think there's a lot of interest in them, but we've now got lithium batteries and we've got PV, and I think cost-wise, that's pushing it out. I have tried to get pricing on hydrogen fuel cells. It's very difficult to get hold of. So until I can get my hands on CapEx and OpEx for hydrogen equipment and assets, you know, we can't really do much planning, and I don't really believe they're going to be deployed within the next 5 years. We'd have to see. I'm always curious. Maybe there are people out there that have better data, and you know, we'd love to hear more from them. Thank you.
Thank you. We don't have any more questions.
So I have then. Can I have a question to Mike, please?
Yes, please.
So Mike, so thank you for your presentation. Really insightful. Yeah, so giving a lot of context of what's going on in South Africa. I was not aware, so thank you. I learned a lot. And I see also that you're ahead of the pack in changing the dominant system model. So up to now, and everyone is holding to it, we have a demand-led model. Yeah, so you can use all you can eat, giving you grid connection. Yeah, and you need to pay as much as you consume, but there is no cap on it. And we are now seeing a need to shift for a supply-led model, where the supply is fluctuating. That is the call for flex in our consumption, and then remain the comfort level. Yeah, so and I think you balance it quite nicely. So that's I think something that you can lead the rest of the world, in how to model it and how to adopt those lines of thinking. So and then on the another part, and that's more of a question. So in Europe, we have guarantees of origin as a government incentive to prove that you have supplied renewable energy to your clients. In North America, it's called RECs, renewable energy certificates. Those RECs have a shelf life of 2 years, so there is a lot of greenwashing around going on.
Yes.
So and there is now a new initiative started up in Europe, in the UK, called Energy Tech, and they have specified the energy attribute certificates with a shelf life of 1 hour. So I don't know if you're aware of it, and I'm very interested to see how you see those movements in South Africa in the building space.
Yeah, thanks, Josh. So look, I've spent some time working and attending the Energy Tag webinars, as you know, big in Europe. The counterpart to that is an initiative by the United Nations, driven by the likes of Microsoft and especially Google. It's called 24/7 carbon-free energy. And the whole idea is that you'll have hourly matching of renewables. In other words, for every amount of energy you use, you're going to want to have a certificate showing that you've somehow got your hands on green energy for that particular hour and for the same grid. So guys in Nairobi, for example, can't claim green energy from Iceland. It's got to be on the same grid, and it's got to be for that exact hour, the 24/7 hourly matching. And that, to a large degree, will remove the greenwashing. So greenwashing has been a massive embarrassment. We know the likes of Coca-Cola and Porsche in many countries have bought certificates, and they've paid people to plant trees. None of that really leads to what we're trying to achieve, and that's have a uniform and transparent reduction in the carbon footprint of entire countries. And that's where the 24/7 comes in. So at the beginning of the year, the likes of Durban, believe it, a little city on South Africa's east coast, a wonderful little city of Durban, got hold of Arup, a big international consultancy company, and they put together a 24/7 carbon-free, for short we call it 24/7 CFE. They put together a game plan looking at just that. So I think we're going to see progress, and certainly the whole of Kenya, for example, the Kenyan government have signed up for 24/7 CFE, and we're certainly hoping, and this is a part that where the excuse me, the Institute can play a massive part is helping our colleagues, the architects, the mechanical engineers, the quantity surveyors, and of course a wide range of property owners and developers understand that it's probably not about how much energy you use, it's when you do use energy, given that it's green energy, okay? So it's about when you use that energy. And Josh, I think that's exactly what your smart building control systems are going to be looking at, right?
Yeah, indeed. Yeah. So, I was listening to an interview with E.ON, I think 3 months ago. It's in Dutch, so perhaps you can understand it in South Africa, where there is an initiative called Ectogrid, in which E.ON declared that they step away from charging per kilowatt hour, moving away like the telcos did by charging for your talking minutes, when there are voice lines, and moving away to energy services. So providing flex, providing energy in at the time that you need it, so preventing congestion limitations and curtailment limitations. So it's very interesting development in some pockets to see that people are seeking for new models. So from E.ON, I understand that if you have renewable energy, you will remove the marginal cost from your business case equation. So you don't need to pay your fossil fuels anymore. Hence, the kilowatt hour price drives to zero. So when they are looking for finding new revenue models to compensate for that.
Yeah, so flexing is big. How do we flex the load? And as you pointed out, so if you have EV charging in your buildings, you're looking at 70%, heating and cooling 70%. There's a lot of flexing that can happen, especially in South African buildings. Now, we've got some pretty effective, I believe, time of use tariffs. And you get punished for using energy during the peak hours. So, I mean, there's a massive incentive there to flex your building. I didn't go into much detail given the 30 minutes, but I think this is a discussion, Oren and Prof Nadu, that we certainly should see. The Institute itself needs to play a bigger part in the tariffs. Energy poverty is very real. We've got to take that into account. And I believe, I know our energy minister is juggling the balls at the moment, how to take care of energy poverty and making sure that the end user pays. There's a lot of interest and concern that buildings which self-generate for self-consumption may not be paying their fair share in terms of tariffs. And these are a lot of interesting things that we have to address. And I believe the South African Institute of Electrical Engineers should be leading the discussion. There's far too many energy experts out there. I attend a lot of meetings with IEEE and the BIPSA and ASHRAE and SIPSI around the world, and Energy Tag as well. And I hardly come across any South Africans. So, the question is, where are South Africans getting their knowledge from? I don't know. But this is where the Institute locally need to jump in, boots and all, and start educating our fellow professionals. Certainly, we know that the Royal Institute of British Architects, the American Institute of Architects have got a keen interest in grid interactive buildings and how you design them. We need to help our local architects and our quantity surveyors and all the associated built environment people understand these issues. So I think there's a lot of work to be done. Oren, I'm grateful that you are taking on the probably difficult task of building up a chapter in the Institute to address this. And certainly I believe, we're all here to support you in this. So thank you.
I'm very happy to hear that, Mike. Sorry, Aaron. I'm very happy to hear that because we can only have a successful session or section with support of the likes of yourself and Mr. Rowling, who are the experts in the industry. And in order to get this and spread the correct news and assist our members with this new systems in place, we can only do that with your help. I've got a question here for Erin from Hagai Satole, who's saying energy efficiency improvements on existing buildings will be a grudge purchase from building owners currently. What can be done to counter this opposition?
Thank you for that. It should not be a grudge purchase if you look at the benefits that you derive from implementing these energy efficiency initiatives. So once you highlight the value proposition and sell it properly, people will begin to understand why there is the need to undertake these energy efficiency initiatives. So that's one of the things that is the building services section we need to put together, that value proposition, and market it out there so that people begin to understand why we need to have these initiatives in place.
Absolutely. It's all about education and also, you know, supplying content in layman's terms. Not everybody who works in renewable energies is necessarily an electrical engineer, but is perhaps an engineering practitioner. And to make them understand how it actually works and where the benefits are is normally crucial. And also about the regular content. You know, the SAIEE has the What Now magazine, which I manage as well. And that's also about content sharing. So if you have any information about building services and you'd like to see it published, please just email it to minx@saiee.org.za. Ladies and gentlemen, we've come now to the end of all the questions. I just want to once again, closing comments from each one of you. Mr. Rowling, you first. Any closing comments?
Okay. So, yeah, thank you for the opportunity to speak to you all. And I have one, I think, call to action, and it is that you please don't be shy with your expertise in South Africa. You have expertise that is not found in any other parts of the world, with a large number of microgrids, and how to manage them, and also the very much agility that you've developed and your deep understanding of black starts. Yeah, so if you talk to in North Europe grid operators, they never experience a black start. So the expertise in handling a black start is totally gone. Yeah, so that's something that you can bring to the world as we all move to more smaller microgrids or mini grids. Having that black start capability and understanding is a true pocket of knowledge that you can leverage. Yeah, so please share, please don't be shy. We all can learn from each other. Yeah, thank you.
Thank you, Mr. Rowling. Mike Barker?
Yeah, so certainly South Africans have, in the last 15 years, a solid understanding of how to work around outages, something that a lot of countries don't quite experience. We know how to handle regular outages and do that efficiently. That's certainly something that we can share with the world. And if I had to leave all of you with just one thought, we can't ignore electric vehicles. We can't ignore the part they're going to play in society. And we can't ignore how they can increase the revenue generation of any and every building in South Africa. There's a massive gap there, a massive opportunity. Again, you know, if any organization can help the country in that area, it's got to be the institute, the South African Institute of Electronic Engineers. Thank you.
Thank you, Mike. Over to our chairman, Mr. Shivara. Aaron, last comments?
Last comment to all you people out there, experts and novices, let's come together and set up this building services section. I think there's a lot of value to be derived from being together and forming this building service section. So please, let's express our interest. Let's send those emails to the email address that was given. Thank you.
Thank you. And ladies and gentlemen, for your attendance to this webinar today, I want to thank you profusely. It's really, we didn't have a big uptake on this because it's such a specialist section, but we thank you for your time. And to our presenters, Mr. Rowling, Mr. Barker, and Mr. Shivora, thank you so much for your time. I really appreciate it. And as you can see on the screen, if you want to get involved in the SAIEE building section, please email bssection@saiee.org.za. I thank you very much for your attendance. Please have a good day. Goodbye.